Hello, this is our fourth video of section F3, and these problems will be covering problems 31 through 70. We have two more videos after this one, and but the good news is they shouldn't be taking that long. So the first two problems are kind of the same, except on this one we're going to locate 3 additional points, and that's all. So the line has a slope of 2. And it's got to go through the point -2, 3. So besides -2, 3, we want to find 3 additional points on that line. So you're going to use the slope to do that. You don't need an equation really on this one, but answers might vary. You might be getting different numbers than somebody else might be getting. But -2, 3 goes right here. Abscissa is -2 and the ordinate is 3, right there. So that's -2, 3. But we want to find 3 more points besides this one that's on that line. So we're going to use the slope. So we're going to use the slope, which is rise over run. So we rise 2 from there, 2 little points, and then 1 over. Now what I want to know is, what's that point? And that's 1 of my 3 that I'll need to find. So you would have to go 1 over to the left, and then up 1, 2, 3, 4, 5. So -1, 5. Now hopefully I'm going to show you a pattern what you could do in a second. So then if you do it again, slope 2, so rise 2 and run 1, and that's another one, and that's 0, 7. Now you may not be able to see the pattern yet, but if you notice the x's are going up by 1 because that's the run, and then the y coordinates are going up by 2 because that's the rise. So if you continue the pattern, the next one should be 1, 9. And that's kind of nice because I'm running out of room to actually plot that 1, 9. But if you go up 2 and over to the right 1, you would indeed be at 1, 9. But there is another one you could do as well. If you look at the pattern going in reverse, there's another one, and this is point number 4, and I don't really need to do this because I only needed 3 in the first place. So if you go 0, 1, -1, -2, -2, then be -3, and then 9, 7, 5, 3, 1. So -3, 1 is another one, and it is. Look here, if you go down 2 back this way, and then 1 back this way, even though I'm not the best artist, I told you I'm not a good artist, they all should line up. So go down 2 and to the left 1. So all these points, it's 4. I only needed 3. So, but that's 3 additional points on line. So now the next one is find an equation of a line. Now notice it said an equation. That means they're not going to be picky here. You can do it in general form, point slope form, or slope intercept form. It says find an equation of a line. They're not going to be picky about it. So what I need to do is find the slope. Well, I'm going to find the slope kind of like I did on number 32 above it here. And I believe this problem here, if I remember correctly, I think it's around 38 or so. Let's see if I can find it real quick for you. 32, let's see. Sorry about that. 39. It's 39 in your book. Forgot to put 39 on. So that's number 39. So -1, 3 and 1, 1. So I'm going to find the slope first. And you go down 1, 2, and then over 1, 2. So the slope is down 2 and over 2, and so it's -1. And notice it should be negative because the line's going down from left to right. Now, what I like to do instead of using the point slope formula, because some of you guys are probably thinking, oh, point slope. Well, I'm going to show you my little technique first. So, y equals mx plus b. That's the way I like to do every one of these problems, that slants. So, -1 is the slope. Now, pick an xy coordinate. It doesn't matter which one you pick. Pick this one right here. I like this one. So x coordinate is 1 when the y coordinate is 1. And then solve for b. And that'll tell you what the y-intercept is. So it'll be b1 equals -1 plus b. So b is 2. And if you notice, that's kind of where I'm at. B is 2. So it's y equals negative 1x plus 2. So that is the equation of the line. Some people are not big fans of that, though. They don't think of it that way. They think of that point slope form. So let me show you how to do it how some of you guys are thinking. You're saying y minus y1 equals m times x minus x1, because it's just kind of been beat in your head in high school. This is how you do it, and it works too. So you take one of the points, so it'll be y minus 1 equals negative 1 times x minus the 1. Put the x1 and the y1 in. They both happen to be 1 in this case. The negative 1 is the slope. And if you do the math, I bet you money that you come up with the same thing. So y minus 1 equals negative 1x plus 1. Negative 1 times negative 1 is a positive 1. And then add the 1 from the left side to the right side, and you get y equals negative 1x plus 2, which is identical to this. But the thing is, you could have technically left the equation like this right here, because they were not stringent on how they wanted you to write the answer. They said just write an equation of the line. So true to form, you could leave it this way, you could leave it this way, or you could actually go back and put them in both of these equations in standard form. Remember in the previous video I mentioned, well, actually general form, I mentioned that you can put these things in the x's and the y's on the same side. I'm going to show you what you would do to put this in general form. So you take this x right here and you move it to the other side. You put the x's followed by the y's. So add the 1x, so you get y equals negative 1x plus 2. Just move this x over here, so it's 1x plus y equals 2. You don't really need the 1. So it's just x plus y equals 2. So that is the equation in general form. So this is point slope form. This is slope intercept form. The point slope form can be reduced down into slope intercept form, and both of these equations can be reduced into general form. So this, or this is acceptable. So which one do you want? I don't care. It says write an equation of a line. So it does not matter which way you write it. They're not going to be picky here. So, okay. Now, this one they're a little bit more pickier, because on 47, 59, and 68, it says find an equation of a line, write in general or slope intercept form. In other words, they don't want point slope form here. The slope is negative 2/3 and containing 1, negative 1. So you do it exactly like 39 works. So what I'll do is y equals mx plus b. Put the x coordinate in, put the y coordinate in, put the slope in, plus b. And so it'll be negative 1 equals negative 2/3 plus b. Add 2/3 to this side, and you get b equals negative 1/3. Now, you get y equals negative 2/3 x plus b, which is 1/3. And that should be acceptable. But this is what I'm already show you why some people like the general form. So this is why general form is widely preferred to some books, because they don't like the fractions. So what they'll do is they'll multiply everything times 3 to get rid of the fractions. So it'll be 3y equals negative 2x plus 1. Oh, yeah, that's right. So multiply everything by 3, that's what you get. And then if you add the 2x to this side, so it'll be 2x, just like I added this x over here to make it x plus y equals 2, I'm going to add 2x over here, so 2x plus 3y equals 1. So that equation and that equation are identical. They provide the same points to the line. So the points on this graph is the points, it's the same graph. So they like this way better simply because there's no fractions. That's the only advantage of this writing. So okay, now I've messed up my thing by holding on to it. So this says parallel to the line y equals 2x, and this says containing the point -1, 2. That's what it said before I erased it. So 59, that's what 59 was saying. So it's parallel to the line, so we're trying to find the equation of a line that's parallel to this one, and it contains the point -1, 2. You're like, it's the same thing as 47, isn't it? Not really. I mean, they give you a point on 47 and they give you a point on 59. They tell you what the slope is on 47 directly. They don't directly tell you what the slope on 59 is. You have to find it. You're like, how do you find it? Well, I use what they tell me. It's parallel to the line y equals 2x. Oh, it's parallel to that line, so they must have the same slope. Well, what's the slope of that line? Oh, it's 2. Oh, you found the slope. So it's parallel to the line y equals 2x, so m equals 2, and now you're no worse off than you was on 47. So y equals mx plus b, so y equals 2x plus b because that's the slope, and then you put your -1, 2 in, so 2 goes in here, 2 times -1 plus b, and I think b turns out to be 4. Because this is going to turn out to be -2 to add to the other side, and that's going to be 4. So it's going to be y equals 2x, because that would be the slope, plus b, which is now 4. Now I prefer the slope-intercept form, even if I have fractions. I mean, I didn't say when I was doing this problem a while ago which one did I want per se, which one would I write the answer. It'd be that one. -2/3 x plus 1/3, even though with the fractions, it's what I need, and it allows me to move to the next problem. See what I'm saying? So it takes, even though this might be aesthetically looking a little nicer because I know there's no fractions, I've satisfied what they wanted me to do. They wanted me to write it in general or slope-intercept form. Even though this might look prettier, this is acceptable, so go on. You're going to learn in mathematics, the longer you stay in it, you do what you need to do and get it done, and because time is always of the essence, especially in exams. So if this was on an exam, don't spend the time to make this look aesthetically better if they said slope-intercept form is fine. So just some tricks of the trade, just a little advice to you as you move through your math courses. So y equals 2x plus 4, okay? That's number 59, so that's the equation of that line. And now number 68, same idea, except this one's perpendicular. So it still contains a point, 0, 4, but it's perpendicular. So you're like, well, they don't tell you the slope. Well, they kind of indirectly they do. It says it's perpendicular to this line. So if I have x minus 2y equals 5, and if I can find the slope of that line, take the opposite reciprocal like we talked about in the previous video, that'll give me the slope of the line that would be perpendicular to that. And now that I'll have the slope and a point, 0, 4, I'm as good to go as I was on 59. So I want to find the slope of that line. So minus 2y equals -1x plus 5. Subtract the x to the other side. Divide by the -2. So y equals 1/2 x minus 5 halves. And the minus 5 halves really doesn't play a role here. It's the 1/2 that plays the role, because that is the slope of that line. So what is the slope of the line that's perpendicular to that one? Well, it's the opposite and reciprocal. So the slope of this one will be -2, because -2 times positive 1/2 is -1, like we said in the previous video. So then I've got a slope and I've got the point. I'm good. So it's going to be y equals mx plus b. So y equals -2x plus b. And this time they tell you the y-intercept directly is 0, 4. So you plug in 0, you get 4 for the y. So b has to be 4. So y equals -2x plus 4. So it ended easily anyway. So that is the equation of a line with these characteristics. So this line and this line up here would meet somewhere in the quadrant, one of the quadrants, probably quadrants, and they would meet at right angles. And these two right here, this equation and this equation, would be running side by side, parallel to each other on the Cartesian plane. Matter of fact, this was going to be y equals 2x, so we go through the origin, and this one right here will be 4 units higher, running right parallel to it, so they never cross. So, all right. So this is F3 lines, our video number 4. We have 2 more videos that follow, and the next video will cover problems 71 through 90. So, thank you for watching.